The notes for lesson 4 are a continuation of the notes from yesterday. So we're still talking about covalent bonds. The notes in your notes packet will start on page 5, which is section 8.2. Yesterday we talked about covalent bonds and some properties. If you remember, covalent bonds share their electrons and ionic bonds transfer their electrons. Again, covalent bonds are made of 2 or more nonmetals. Ionic bonds are made of a metal and a nonmetal. So the structures that you are drawing over the next few days are just covalent bonds. And because they're covalent bonds, they are going to share those electrons. So you will also want your periodic table. Don't forget that. Always have that. But here we go, page 5 of your notes. So I'm also going to use the whiteboard behind me to do some of the drawings in the slides. So section 8.2. In covalent bonds, electron sharing occurs. So again, those electrons are shared so that all elements obtain a noble gas configuration. So noble gases have 8 valence electrons. They are happy and stable, and that's what all atoms and elements are trying to achieve. So covalent bonds share their electrons so they can have that noble gas configuration. A single covalent bond, so we're going to get into single bonds, double bonds, and triple bonds. A single covalent bond is when 2 atoms share 2 electrons. So I'm going to put my camera into full screen so we can draw these Lewis structures, or the shapes. Just so you know, today I'm going to kind of go through the process, explaining each step, but tomorrow in your notes, you will write down more of a step-by-step process when you have to draw them on your own. So don't panic if you're a little confused as to how to draw these today. Over the next 2 or 3 days, hopefully with those steps and practice, you will have it down. So tomorrow you will get more of a step-by-step process. All right, here we go. So F2 is our first example. So for F2, that 2 represents that we have 2 fluoride atoms. So we're going to put 2 fluoride atoms side by side. And then the first thing you have to do is you have to look at your number of valence electrons. So fluorine is over here in group 7. So fluorine has 7 valence electrons. So I'm going to draw 7 dots around each fluorine. So fluorine has 7 valence electrons. It wants to share 1 more, so it can have a total of 8 to be like a noble gas. So what happens is these 2 electrons form a bond, a single bond between the 2, so that these 2 electrons can be shared by this fluorine, and these 2 electrons can be shared by this fluorine. So when you circle around each atom, you would count these 2 electrons for this fluorine. So here would be 2, 3, 4, 5, 6, 7, 8. These 2 would also get counted for the second fluorine. So here would count 2, 3, 4, 5, 6, 7, 8. So both fluorine atoms have their full octet. They are both stable like a noble gas. So this is what a single bond would look like. The next example is NH3. So again, tomorrow you'll get more instruction into this, but to figure out which atom will go in the middle, if there's more than one atom, usually those atoms are going to be in group 4A or 5A. Generally, those are our central atoms. So in this case, nitrogen is going to go in the middle, and then we'll put our 3 hydrogens around it. All of the structures that you'll draw will have a central atom, and then elements coming off of that central atom. You will not ever have any that are enclosed like a triangle or a square or anything like that. They will all have a central atom, and then we'll branch off from there. So next we have to look at the valence electrons. So take a second, pause the video, find nitrogen, find hydrogen, and mark down the number of valence electrons that they have, and then unpause, and we'll draw our structure. So take a second and pause. Did you really pause? All right, here we go. So nitrogen has 5 valence electrons. So I'm going to draw 5 electrons around my nitrogen. Sorry, I'm going to reposition these. So we have 5 electrons around nitrogen. Hydrogen has 1 valence electron. So I'm going to draw 1 electron on each hydrogen. Now, nitrogen has 5 valence electrons. It wants to share 3 more to have a total of 8. So nitrogen is going to form a single bond here, a single bond here, and a single bond here. So those would be our 3 single bonds. Remember, a single bond counts as 2 electrons. So if we circle around nitrogen, we would have 2, 4, 6, 7, 8. So nitrogen has a total of 8 electrons. It is stable. It is good. Hydrogen is only sharing these 2 electrons from a single bond. Hydrogen is the exception. Hydrogen will never have 8 valence electrons. Hydrogen is in energy level 1 of your periodic table. So in energy level 1, you only have hydrogen and helium. There's only 2 elements. So hydrogen can only ever have a single bond. It can never have 8 valence electrons because it's in group 1. It will only ever share a single bond. So one other thing that you'll notice in the drawing is these little electrons up here. That is your next definition. So I'm going to minimize my screen. So the unshared pair or lone pairs of electrons are electrons that are not shared between atoms. So this would be a lone pair of electrons. And that those 2 electrons would count as 1 pair. So anytime you have extra electrons on the central atom or on any atom, they are unshared pairs of electrons. When those unshared electrons are on the central atom, then they can change the shape of the atom, which then can change the properties of the atom. So even though these electrons are not bonded to anything, they are super, super important. They're just as important as a regular bonded atom. All right, here we go with the double bonds. So a double covalent bond is when 2 atoms share 4 electrons. And again, we'll go full screen so you can see how a double bond looks and how a triple bond looks. So a double bond is when 2 atoms share 4 electrons. So the example shown is CO2 for a double bond. Again, I'm going to go full screen so you can see the drawing a little better. All right, so we're going to try CO2. So again, if carbon is in the compound, carbon is in group 4, so carbon will always be central atom. So we're going to put carbon in the middle and the 2 oxygens on each side of it. So now take a second, pause the video, count up your number of valence electrons, and add them in on the drawing. All right, did you count the valence electrons? Okay, here we go. Each oxygen has 6 valence electrons. Carbon has 4. And this oxygen would also have 6. All right, so oxygen has 6 valence electrons. It wants to share 2 more electrons to have a full octet. Carbon has 4 valence electrons. It wants to share 4 more to have an octet, a full 8 electrons. So these 2 electrons are going to get shared in a bond. These 2 electrons will get shared in a bond. So now oxygen has 2, 4, 6, 8 electrons. Now on this side, carbon still needs to share 2 more, and oxygen still needs to share 2 more. So what happens is these 2 electrons are going to bond with 2 electrons from this oxygen. So I'm going to actually reposition these so they're a little nicer for my drawing. These electrons are going to share in a bond, and these electrons will share in a bond. So now if you look at this oxygen, it's sharing 2, 4, 5, 6, 7, 8. carbon would have 2, 4, 6, 8. So remember, those bonds get counted for each atom that they are connected to or next to. So this would, carbon dioxide, would have 2 double bonds in the structure. And again, tomorrow you'll get more insight as to how to draw these step by step. All right, last one is the triple bond. So a triple bond is when 2 atoms share 6 electrons. So an example would be N2. Okay, I'm going to go full screen again. So N2, you put your 2 nitrogen atoms side by side. Take a second, count up your valence electrons. All right, so nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you draw in those valence electrons. So if each nitrogen atom has 5 valence electrons, it wants to share 3 more to have a stable octet. So these 2 are going to form a bond. These 2 are going to form a bond. These 2 are also going to form a bond. So I'm going to move these and just reposition them. Again, so my drawing is a little nicer. So this would be a triple bond, which would count as 2, 4, 6 electrons. So you will have either single bonds, double bonds, or triple bonds in the drawings that you do. And again, tomorrow, whoops, oh, that was fun. Okay, so tomorrow, again, we'll do more of a step-by-step process as to how to draw these Lewis structures. All right, we're going to go through one more example just so you can see the difference between the two. Okay, so this slide has ionic and covalent. So ionic, if you remember, is a metal and a nonmetal, and ionic transfers their electrons. So if you have an ionic compound, we'll make our box here. If you have Na2O, this is where you have the arrows and you show the electrons being transferred. So sodium, there are 2 sodium atoms in the structure, and each sodium would have 1 valence electron. Oxygen, you only have 1 oxygen in your structure, so 1 oxygen would have 6 valence electrons. So this is where sodium would completely give its electron to oxygen. Oxygen would take those electrons. Let me write and add one more thing down here. So once sodium gets rid of its electron, it ends up with a +1 charge. When oxygen gains those 2 electrons, it would have a total of 8 electrons. And then what we usually do is put brackets around that negative structure, showing, I'll put this down a little more, showing that this atom gained those 2 electrons. Because it gained 2 electrons, it would have a -2 charge. All right, so now we will draw our ionic one, or sorry, our covalent one. So covalent is NF3. So I'm going to make a box over here. For covalent. So NF3 is our example. So nitrogen will be our central atom. So we're going to put nitrogen in the middle and the 3 fluorine atoms around it. So again, you have to count up and add in your valence electrons. So nitrogen has 5 valence electrons. Fluorine would have a total of 7. All right, so nitrogen has 5 valence electrons. It wants to gain 3 more to be stable, like a noble gas. So with covalent compounds, these electrons get shared between those atoms. So NF3 would have 3 single bonds, and nitrogen would also have this lone pair of electrons on the central atom. So again, that's just to compare ionic and covalent. All of the drawings that you'll do over the next few days will be covalent. They will all share their electrons, and then in turn, they will have special properties. So hopefully this helps. We'll do lots and lots of practice in class. Hang in there, you guys are doing great.